Assalamualikum OyaRahmatullahe OyaBarakatuhu. Innal hamdanillah wassalatu wassalamu ala rasulillah. Amma ba'd. Bismillahirrahmanirrahim. This is Muhammad Kamrul Hussain, Department of Business Administration, Metropolitan University, Sylhet. Welcome to my virtual classroom, MKA CLASSROOM. Now let's start today's video tutorial.
Today we will try to start risk measurement. In addition to considering the range of returns that an investment might produce, risks of an asset can be measured quantitatively by using statistics. The most common statistical measure used to describe the investment risk is standard deviation. So, for the measurement of risks, we use a standard deviation as a statistical tool for measuring risks. Now, what is a standard deviation? The most common statistical indicator of an asset's risk. It measures the dispersion around the expected value. Dispersion around the expected value. The standard deviation, sigma, measures the dispersion of an investment's return around the expected return. The expected return, R bar, is the average return that an investment is expected to produce over time. For an investment that has different possible returns, the expected return is calculated in this formula, R bar equal to summation Rj into Prj. So here we will see R bar equal to summation Rj into Prj. Rj into Prj. R bar expected return. Rj means return for the zth outcome. Rj return for the zth stock or zth asset return. Prj probability of jth stocks. Probability of jth stock. Probability of occurrence of jth outcome or jth stock. N number of period or number of outcome consisted. That is our expected return formula. Such as for an example, it is a x and y. It has the 10%. It has the 20% return, and probability 0.5 and 0.5. So expected return should be in this way: R bar equal to 10% into 0.5 plus 20% into 0.5, that means 15% is our expected rate of return if we use this formula. So here we will see another formula where has no probabilities. Then we can simply calculated R bar equal to Rj, summation of Rj divided by number of n. The formula for finding expected value or R bar when all outcomes Rj are known and their related probabilities are equal is a simple arithmetic average. That means all probabilities are equal or non-equal. For I have said that there is not given probabilities, that means equal probability. Then you can write down the formula summation Rj divided by n. As like in the previous examples, we will see 10% plus 15%, and our number of stroke is 2. So what will happen? 25% divided by 2, it is equal to 12.5%. So here 10 plus 20 in our previous example divided by 2 equal to 15%. So it is, I have write down 15%, so that's why it is 12.5%. So 15% is our average. Equal, that means here is the 0.5 equal probabilities, so it shows the equal probabilities. Now standard deviation formula for the standard deviation, sigma equal to root over summation Rj minus R bar expected return into PRJ. So that is the formula for our standard deviation, root over summation Rj minus R bar into PRJ. R bar whole square, Rj minus R bar whole square into PRJ root over. So this is our formula for finding standard deviation. So we, by the using this formula, we can find our standard deviation SD. Standard deviation or sigma equal to Rj minus R bar whole square summation into PRJ root over. So this is the formula for standard deviation formula. So in the previous examples, previously we have seen that standard expected rate of return, whereas no probability or equal probability. So in the same way, here is the another formula for where we can use the same probability or given no probability. Then the formula for standard deviation we can write down in this way: standard deviation over standard sigma equal to root over rj minus r bar whole square, rj minus r bar whole square summation divided by n minus 1. So formula, so we will see the formula where we are using equal probabilities. Then formula for equal probabilities are given no probabilities. So summation rj minus r bar whole square divided by n minus 1. That is our formula, whereas not given the probabilities were using the equal probabilities. So after that we will try to see coefficient of variation. For the measuring risks we will use CV. Coefficient of variation is simply sigma divided by r bar, or risks divided by expected rate of return. Risks divided by expected rate of return. We are using this formula to calculate coefficient of variation. Coefficient of variation usually used for per unit risks. Per unit risks that is used for per unit risks. So coefficient of variation, a measure of relative dispersion that is useful in comparing the risks of assets with differing expected returns. So basically CV you use only when the standard deviation has different expected return. In this case we have to comparing different project, we have to use coefficient of variation for comparing the result. So I may make you understand that if r bar is different, for the different stocks, then you have to use coefficient of variation for taking the decisions, because CV can show per unit risks. So here we will see coefficient of variation. CV is measure of relative dispersion that is useful in comparing the risks of assets with the differing expected return. If expected return are different, then we have to use coefficient of variation for taking our decision. So that is too much important for us, because sometimes the expected rate of return are different, then we have to calculate CV to make our decisions. Otherwise we can take decisions with the standard deviation where expected rate of returns are equal for the different types of asset.
This all about today. Stay home, stay safe, try to maintain a safe social distance. Try to wash your hands frequently in a day. Subhanaka Allahumma wa bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaika. Assalamualaikum warahmatullahi wabarakatuhu.